Hi everybody, this is Houdini Forces. Let's do some destruction. Okay, in this video we are going to talk about destruction in Houdini software. One thing I want to say that I don't start teaching topics like a classroom. But here we start to test some curiosities in Houdini software about what it can do and what is the algorithm to do things and what different ways it can provide us and what creative ways we can discover. So here in the beginning, I would say that the ways I introduce are probably not the best solution. So I want you to share your own ways with us so we can reach a better and optimal solution. Okay, let's first examine the principles of destruction in Houdini. First, we should have a clear vision that a destruction in Houdini, how it starts and how go forward. When we have an object and we want to destruct it, we have three main steps to simulate the destruction. First of all, we have fracturing. When we fracture an object, we break it into the pieces that we want to use them later in the simulation. In fact, in simulation, our object will break to the form of these pieces, and that's why we should customize the fracturing. We change the destruction in the way we want. So we can conclude that the fracturing should be our first step. There are two main ways in Houdini to fracture object. First, Bernoulli fracture and then Boolean fracture. In the Bernoulli fracture, we need the object and we need some points. And when we connect this to our Bernoulli fracture node, this node starts and with a greedy algorithm break the object to pieces like this based on position that the points have. And I usually don't use a lot of Bernoulli fracture in destruction because I think usually objects don't break to the pieces like this. And about the Boolean fracture, we still need an object like this, and then we have a second object that is our cutting object. When we connect this cutting object to our Boolean fracture node, this cutting object will act like a blade and cut our object like this, and our fracturing will have detail as much as our cutting object have detail. Okay, let's go to our software and see how this Bernoulli fracture and Boolean fracture works. For Bernoulli fracture, we need an object and we need some points. If we scatter some points On this sphere, we see that the points are just on the surface of the sphere, and there is no point inside the sphere. If we Voronoi fracture the geo with these points, we will see that our pieces, it's too much. We will see that our pieces are like this, and there is no piece inside the sphere. Every piece starts from surface because the point is on the surface and go through to the middle of the sphere. To change this, we can use VDB from polygon and use a flag VDB to have density. When we have density, we can scatter points by density, and then we have points everywhere we have density, and we can see there are points on the surface and inside of the sphere. And then if we fracture the sphere with these points, we can see there are pieces inside the sphere, there are pieces on the surface, and I think it looks better. If you want to use a Boolean fracturing, as I said, we need an object, and we bring Boolean fracture node. We need a geo and we need a cutting surface. For a cutting surface, we use a grid, and then we need a mountain, okay, like this, and if we connect it to our Boolean fracture, this grid cuts our sphere like this, and we can see as much as we have detail on the grid and the cutting surface, we have detail inside the piece, inside the piece of our sphere.
And before we continue, I want to say it takes a lot of time for me to make these videos, and it's very supportive for me if you subscribe and like my videos. This means a lot to me. So I would be grateful if you could do it now. Thank you.
Okay, now let's think we want a ground object like this, and we want to destroy it. Let's think this is our ground object, and we want to destroy it. And first we should fracture it. We use Boolean fracture, and we need a cutting surface. As I said, I bring this sphere for our cutting surface, and I bring a mountain and cut our ground with this sphere. And we can see that, so you can see that we have piece like this in the middle of the ground, and I think it's good and good detail inside, and it's just a small piece of the ground. To fracture all these ground object, I use a technique like this. I scatter points on this ground object, and then like this, and then I copy points and connect my points, and then connect my object, and then we have 100 of this sphere like this. We can cut the ground with these 100 of pieces, and it's like a cheese. We can see it's like this. Okay, it's good, but not enough, because these spheres are same, and we want to change and randomize them. To this we bring a attribute randomize, and not color but normal. We change to normal, and we can see the rotation of each point, and then each sphere is different. And then we can bring point angle and randomize our P scale attribute with a rand function, and the attribute called num that is different for every point. And then we see we have very small spheres near the 0, and we don't want this, so we fit it to 0 to 1. And for our attributes we create channels, to float channels called min size, and the other one called max size, and okay, we click this button and select our min and max size. We can multiply whole of it to a new channel called size multiplier, and okay, again we click this and we can multiply it to 1.5. We can see we have different random rotation, random size, but one thing is same in every sphere, and it's the shape of every sphere is the same. Yes, we have random rotation and random size, but the shape and noise is the same on every sphere. For example, when we change our time parameter in mountain noise, we can see the noise and the shape of a sphere will change, and we can use this. And to randomize and change this shape and noise for every sphere, we can use for each point loop and create a metadata, and we connect our points, and here when we connect this and then this, we have our object for copied point node and our points, and here in the mountain and in the time parameter we can reference our value to a scene data called in the for each metadata attributes and global and iteration, and we have different value of type for each point, and then for each sphere, and we have different shape for every one of our sphere. Now we have a good set of cutting surfaces, and we connect it to our Boolean fracture, and we have our object. Then we can see the result, and we see it's random and different. And also we can scale up our spheres like this to have bigger and more details pieces. But as you can see, these fractures are not in a row and in a line like usually a destruction of ground is in the nature. And for example, it's because we have points scattered in the wall of our ground object, and it can be customized and changed to the shape that we want. And for this we can use a attributes paint node. We have these object, and we want to paint attribute, and as we use the density attribute to scatter points on the object, we change the attribute we paint to density and use press enter, and we scale up the radius, and we change the shape to the screen to when we paint this side of our ground, the other side will have the same value. Our points will scatter by the density, and it's like this, and after that we will have our fields like this. We can down the numbers of the points, and there are lots of pieces, lots of detail inside and outside, and we can again scale up the detail of inside, the scaling up the detail of our cutting surface, and I think it's good. And one other thing is that we have some big pieces like these and these, and also we can fracture them again, and so we use a node called connectivity, and we use connectivity type of primitives, and then we bring a node called measure, and we use it by piece. You can see the small these nodes measure the area of each piece. The biggest pieces are in this color mapping, they are red, and the big pieces here are red. The smallest size blue, and the middles size are white. And we can use a delete node, and by expression we can say delete every piece that the area is under 5. For example, if you see the spreadsheet in the primitives, you can see, for example, this class has the area of 9.47, and for example the piece number 61 has 2.4 area, but we can For example, with this, also this, or this. Okay, and we have these big pieces. We can name it big piece, and we can also have the edit non-selected. Here is the pieces that we delete, and here is the other. If we merge them, we will have all the pieces. But we want to Voronoi fracture these big pieces, and for this we use a VDB from Polygon. We use fog for density, then scatter points by density, and 50 points, and then we only fracture them. And after all, if we see the result, we have lots of detail in the middle, and big pieces are fractured. Also, you can use Boolean fracture also for fracturing big pieces or Voronoi fracturing. Okay, in our next episode of this destruction series, we will talk about the second main step. It's constraints that show us how these pieces can behave to each other, and how our software keep these pieces together. And our third main step is simulation, that we do it in top level. See you in the next episode.